Hi class. Well, today we're going to be talking about the RSA Cryptosystem. The group is done by me, Dion David, and Adi. So let's start with the background of RSA Cryptosystem. The topic covered in class. This presentation will cover more in-depth topics about the RSA Cryptosystem, one of the first public key systems used for secure data transmission. RSA stands for the creators of the crypto system. The people that created the RSA crypto system are Ron Rivets, Adi Shamir, and Leonard Edelman, hence RSA. There is no need to exchange secret keys between messages happening from party A to B. The significance of the RSA crypto system is that one of the most widely used public crypto systems throughout the world is RSA, and some of its basic uses are one-node authentication and mutual authentication. We'll get to some of its uses later. The main intention is to encrypt messages with the public key so that they can be decrypted in a reasonable amount of time. This helps protect sensitive information from adversaries. The crypto system paved the way for more modern public key crypto systems. Some of its security considerations, despite the negative stigma around RSA, is that it's really secure in today's world. Even if an adversary would intercept the message, they would miss a vital part of the information. Exponent D. RSA tokens are used for helping adding another layer of security when a user would want to access a certain service. So technically, the RSA operation cannot handle longer than a modular size. That means a 2048-bit RSA key, you would be unable to directly sign any messages longer than 256 bytes long. So there are some drawbacks there, which is now being changed due to new quantum cryptology. Another very important use of RSA is for digital signatures or digital signings. The steps for digital signings start with creating a message. Represent this message as an integer m between 1 and n minus 1. Use the private key nd to compute the signature s equal m to the power of d modulus n. Then send s to party B. This is just one way of how digital signatures work. Digital signatures in which a ciphertext generates with a private key can be decrypted by anyone who has a public key. This verification proves that the sender had access to the private key and therefore is likely to be the person associated with the public key. In the public and private key system, the key pairs can be easily generated for encryption and decryption. Now Adi will take over for the remainder of the presentation. Hi class, and I'll be demoing the interactive website that we have made for today. The link will be available in the presentation, or you can add a professor for the link in case you want to know about the RSA encryption algorithm. The website is split into 4 sections. The first is the RSA cryptography and its basic origins and definitions. The second is functionality, uses, and the ways of attacking RSA. The third is the algorithm that is embedded into an interactive web page. And the fourth are just basic resources and websites that we used as a source. So the first part being the RSA algorithm and its basic definitions and its algorithm itself includes the key generation algorithm, the practical steps one by one, encryption, decryption, digital signing, signature verification, and its processes about a more secure method as well, and the older method. The second part is the functionality, which includes four possible approaches to attacking the RSA algorithm. The first shows as brute force, the second is a mathematical attack, the third is timing attack, and the fourth is a protocol attack. And we explain in small depths about what each of these attacks do and how they're done, and the conclusion of how secure RSA is. The fourth part is the algorithm and the interactive web page itself. Now, this is embedded like a form where you get to fill out your own prime numbers and encryption keys. So for the sake of this example, I'll choose P as 3 and Q as 11 and set that. Now the encryption key, public key E, gives me a bunch of options to select from. So I say I choose 11. And now D gives me a value saying I need to choose 11 as well. Now the message I want to encrypt would be, say, the number 47, and it will show me the encrypted message and the decrypted message. If I wanted to use 121, it will show me the encrypted message and decrypted message as 22. So this is how the RSA algorithm works, and this is just a way to understand better how a symmetric encryption algorithm of the RSA works.
So the next step we have is basically signature verification. And in order to help with signature verification, here's the steps that are involved. So party A's public key, integers n, and then the exponent e is going to be used to compute an integer v equals s to the power v mod n. Then you will compute its message h prime. Then after that, you're going to compute the expected representative integer v by encoding the expected message h prime. And if v equals v prime, then your signature is valid and in turn it's ready to use. So the advanced schemes about the RSA algorithm is the first one. There's like many RSA advanced schemes, but here are the main ones that we will talk about. First one is the RSAESOAEP. This is a technique that helps mask your messages, and the function that is used to help that is based on the hash function. The RSA SSA PSS is a technique to encode your text before creating a signature, and also develop modern methods of security and has a security proof too. And the Ferguson Schneider encryption, which is using RSA to encrypt random messages and utilizing a hash function to get the encryption key. And for the parties, the same modulus is being used for the signatures and encryption. So some of the weaknesses or like attacks I would say within RSA is you could have a small encryption exponent, which is known as a low exponent attack. If a small exponent is used and there's no random padding, then the adversary can retrieve the message easily. The small encryption exponent in message, which is known as like a short plain text attack, when using a small exponent and having no padding, then the ciphertext can be broken down by computing its cube root. And this shows that when RSA would work when m to the e is greater than n. This using the same key for signing and encryption. If the hacker gets a key holder to sign from an unformatted message and using the same key, the original key is received. Then using a common modulus for different users, using the same modulus, it can make a user's computer private exponents for other users. They can get the private key for other users and hack into a system. So the industry uses are a little RSA secure ID. This is a key fob that's used when you're logging into various services like banking and like many other uses for it, and you're going to be help secure sensitive data from point A to point B, and 1,500 companies basically use this key fob to help protect customers' valuable data. Well, that is it for our presentation. Thank you very much for your time. If you have any questions, let us know.